Hi everyone, welcome to another video in the CBM Flux Studio series. Today I'm going to show a few observations that I made while working on the VMAX decoder. A shout out to Game Time Warp on YouTube for pointing out some of the alleged issues with G64s produced from NIB files that are available on the internet. So the feedback that made me think about this was about syncs. There was a mention about syncs not being quite right for the emulation in the latest version of Vice to work. So I started digging, and I found one possible cause for that. But before we get there, I'd like to show something that is related but not quite the same thing. I've got a NIB file here for California games, which is Vorpal. Now if I go to track 27, there is something peculiar here. Let me see, this is ID 21, so I'm not too far from the track cycle here. I want block 0, and there we have it. So this is block 0, and after that block there is the CBM header for sector 0 on this track. As you can see, the size of the sync, which is also displayed in the tooltip now, and that's one of my latest additions to try and do this sort of analysis. So the size of the sync is 37 bits, so they're all set. The previous one is 38, here 37, which is not divisible by 8, but nonetheless that's not what I want to show you. Further down in this NIB file, the very same block sync occurs again, and all I have to do is to try and find where block 0 is. Yeah, so it's just here. So this is block 0 again. Again, remember the NIB files have more than one revolution per track. If I go now to the CBM header sync, yeah, that's where it is. It's just over here. You see, at this pass, it's 45 bits that it recorded in this block sync. Now the difference is 8, which is really suspicious. It feels like in the previous pass on this block sync, some of the bits, 8 bits, a whole byte, has not been recorded properly at the receiver. I have no idea. I mean, I don't know much about the provenance of these NIB files, but I noticed this when I changed the way that I convert to G64 and then align to Vorpal. So the track has been shortened, but if we go to again to track, was it 24, 27, and then we have a look at this one. Now what is in the final G64 data is the longer sync, where before I was picking up the other one. So I was doing comparisons between the G64s I was generating earlier and this one, and I found out the discrepancy. And I started looking at it, and I found out that, yeah, in different passes, different sizes have been recorded. This is already alarming on itself, but again, I don't know the provenance of the NIB file. It could be that there has been manual manipulation of the track. It could be that the receiver side of the process wasn't able to recorded the byte, something went wrong. I have no idea, if I have to be honest. So there is that, which again is a little bit alarming, but what can you do? Now, in an earlier video, I was showing the block sinks for Afterburner Site 2 in a G64 file created by CryoFlux DTC. Have a look at this one now. Let's convert to G64 and then align to Vmax. Now, as I said, the alignment is a work in progress, but what we have here is that all the block zeros, the start of block zeros have been brought at the beginning of each track, where the block sync is still not moved yet. Have a look at this. So this block sync is 14 bits, which is absolutely fine to trigger the hardware for a block sync. Again, you can have as many as you want. The absolute minimum for reliably detecting the framing essentially is 12. There isn't much room for that. The hardware can work with 10, so that's fine, but the software needs a lift to 12, and there is, you know, jitter there, so that's the reason. Now this one is fine, 14, but this is 10. It's too small. This is 11. Again, they are too small. 10, 14 again, 15, 8. This is really too small, and 10. Let's have a look along the track. Sectors are quite well aligned in an area with the same density. So let's have a look at this one. This one is 15, 15, 15. Don't worry about that one yet. 15, 15, 15. So, you know, they're pretty much consistent in this case, which is good. We go here and it's 15, 15. I mean, very consistent. So what causes the one for block 0 not to be consistent and not to be a lift 12? I'm not sure. Again, I don't know the provenance of these files. Yeah, this one doesn't look right here. It's just 7. But 7 plus 8 is 15, which means that, you know, possibly a byte has been missed, has not been recorded in this sync. All bets are off, really. All bets are off. Again, there is an exclamation mark in the file name for this NIB file, so I mean, can't quite remember whether that meant that it was manual manipulation. Again, this is probably not the sort of material I want to work on if it's been manipulated. Let's now have a look at the DTC version again of this disk. We align to the right splices. Look at that, 12, 12, 12, 12. 12 in all cases. This is block 0 for Vmax. Now let's try and go to block 1. 12, 12, 12, 12. I mean, it's very consistent. So I think that for NIB, for G64 files produced from these NIB files, where it appears there are a byte worth of things missing at times, I can see how the drive code could have problems. I mean, would have problems to frame the blocks. There was one with just 7 bits that we saw earlier. That one I'm not quite sure whether the code, the disk drive code, would be able to frame. I mean, you need 10 realistically, at least, but we say 12 for reliability. We have 7 here. Probably this block on track 33 is going to be problematic. Again, there are exactly a byte worth of bits missing in this sync, which is incredibly suspicious. Again, I don't know if there has been manual manipulation, but yeah, I can see how this is going to be a problem. Now, if this happens systematically, then we might want to find out why this is happening and, you know, fix the nibbling routines. Probably not in NIB red, but at least in the IC host NIB tools, and make sure that this works fine, which also means, you know, I would have to rely on people who actually own these VMAX version 3 disks to provide fresh NIB files in order for me to assess what's going on here, whether this file has been manipulated or not, or it was produced this way. Again, if it's something we can fix in the firmware and in the software, then that's the first port of call. Then if it's something that happens and has happened in the past and we want to, you know, be able to cope with, then maybe I should have an option that, you know, warns on these short syncs. I mean, it's still possible to fix these ones because the pattern in the, you know, after that is very regular. So it's entirely possible to extend this one by it, because it's just by one byte. It's very easy to insert 8 bits in here, because it doesn't change the fact that the track is a whole number of bytes inside. But again, I'd like to understand what has caused these missing bits, and if it's something that happens occasionally, it's due to, you know, somebody forgetting to put them in, it's something that happens in certain passes. I'd really like to understand why this is not working before making further suggestions on this one. But yeah, I can definitely see that some of these things would be problematic. And that was it for this video. I hope you enjoyed it. Thanks for watching and see you in the next one.